as I was just saying a second ago, you definitely want to double check all of your work, thank you, before you pass in your test. And I'm hoping we can finish this together as a class, but if we can't, the last problem, and a couple of problems actually have to do with what we were just studying yesterday, so you could probably finish them on your own, but no matter what, I will do them on a recording, all right? So if you need to, you can finish up watching this tonight. Alrighty, solve the system by graphing. Well, when we did this in class, we used our graphing calculator every time, and so we solved them both for y. We wouldn't have to do that here. We certainly could. I'm going to color code my 2x minus y equals -1. And yeah, probably most of you are real comfortable getting y by itself anyway. So what would you do in that one? Would you do the thumb method, or would you get it y equals? Thumb method? Okay. If you were quiet, somebody else beat you to the punch. They showed me the thumbs. All right, so we cover this up. Negative of something is -1. What would the something have to be? 1, yeah, bless you. Because then it'll say -1 equals -1. And if y is gone, it says 2 times something is -1, so we divide by 2. Now this is why I said you might want this one y equals mx plus b, because we have 0, 1, and we have -1/2, 0. It's awfully hard to get a nice straight line when they're that close together. So you might want to go ahead and do this one y equals mx plus b anyway. Having both methods is great. So subtract 2x from both sides. Divide by -1. And that'll just give you a little bit of space, you know, because you can see, oh, good, I was right about that 0, 1. This is my y equals mx plus b. And my b is right. But now we can use that slope of 2 to go up 2 and right 1. And that gives us something to aim at. And you could use it backwards as well. So back 1 and down 2. And tomorrow I'm going to give you, basically it's a piece of cardstock paper. It's, you know, really thick paper, so you can use that as a straight edge. Today, just try the best you can to get that line on there. All right. I know we've used colored pencils before. One of the things that's bad about using colored pencils on a test is you can't erase them. So if you've been really good at this and you want to use your colors tomorrow, you can absolutely do that. But you won't be able to erase, so you have to be careful. Second one has 1/2 x minus 2 equals y. So is that thumb method or slope-intercept form? Yeah, that's already slope-intercept form. So where does that graph start? -2. Start with the b. There's -2. Where do we go from there? Up 1 and over 2. So up 1 and right 2. Again, I'm going to give myself a bunch of things to aim at. I'm going to use my slope backwards. Now, if you use the slope backwards just once, you'll notice, hey, that hits my red one right there. Because where is our solution? It said solve it by graphing. How do we know where it is? Well, how do you know that? Jacob. It's where they intersect. Exactly. That's what we've been trying to find all this time. So let's see. That's at -2, -3. You get done with the test, you see there's 10 minutes left on the clock, and you're like, gosh, I hope I graphed that right. Don't hope. Put them back in. Plug them back into the original and make sure they work. They're supposed to. If they don't, you graph something wrong. So you can absolutely double check and make sure your answer is right for that one. Going to be okay with this one tomorrow? Graphing to solve? All right. Oops, it looks like that was the only one I fit on this page. So this one says you don't have any choice. You have to show us that you know what substitution is. Solve the system using substitution. Is this a good substitution problem anyway? It is, isn't it? So what do you think? You want to get the x or the y by itself? We're kind of used to y, right? So let's subtract x from both sides. So you can either write it as negative x plus 3 or 3 minus x. It doesn't make any difference. Now that we've done that, what do we do with negative x plus 3? Yeah, substitute it in the top one for y. We're saying y equals this. So the top one that we haven't used yet will look like that. And with just a little bit of algebra, we should be able to tell them what x is. So you distribute the negative 3. Be careful, there's a lot of negatives there. Negative 3 times negative x is 3x, and negative 3 times positive 3 is negative 9. Combine your like terms. Add 9 to both sides. And divide by 8. Well, that's good news, right? We get a nice integer. I mean, usually that's telling you, hey, I did something good here. But that's only half of the answer. So how do we get the second half of the answer? Yes, exactly. Go to that nice easy y equals, bless you, equation that we had. So y equals negative 1 plus 3, which makes it 2. Now, on that line over there, should we write x equals 1 and y equals 2? No. Remember, we're supposed to show this is where they hit each other on the graph. So we write our answer as an ordered pair. That connects it with the graph. So it's not going to cost you a lot of points if you don't do that, but it is a big deal, that we understand that's what we're getting. Alrighty, next one says substitution is out. Now we have to use elimination. So take a look at this one. Would this be a good elimination problem anyway? Well, how come? The y's are already opposites. Fabulous. Less work for us. We'll just add those together. So 2x plus 4x is 6x, and negative 3y plus 3y is 0. And then we've got 14 plus 46, which is a very lovely 6d. Oh, nice numbers. X is 10. Unlike substitution, where we get the first answer with quite a bit of work, and then it's really easy to get the second one, it's usually a little harder to get the second one with elimination. So, would you use the top or the bottom equation? What do you think? Top has smaller numbers. Yes, it does have a minus in it, but it's got smaller numbers, so let's go with the top. 2 times 10 minus 3y equals 14. Well, that's 20 minus 3y. That equals 14. And then we just solve away. Subtract 20 from both sides. And divide both sides by negative 3. So how are we going to write our answer? Yeah, parentheses in the sky. 10-2. Just make sure you write them as x, comma, y. And you've got it. So far, so good? I remember when we did this, there were a lot of people saying, I love this. It's like easy algebra stuff. Yeah, once you know how to start it, should be some pretty easy 2-steppers, 3-stepper equations. Now this one says we get to pick. Solve the system using either substitution or elimination. So what do you think? Yeah, I would use substitution on this one. That bottom equation, really fast, subtract an x from both sides. And again, you could solve it for y as well. It's up to you. And then we realize we haven't used the top equation yet, so wherever there's a y, we have to plug in negative x minus 12. And then, of course, lots of negatives, so slow down a little bit. Negative 3 times negative x is 3x, and negative 3 times negative 12 is plus 36. Combine like terms. And then we're going to subtract 36 from both sides. And divide by 5. Bless you. Okay, I got negative 6. Is that what you got for x? Bless you. We're obviously not done, right? Where does that go? Yeah, my red one up here. So that will say y equals the negative of negative 6 minus 12. Well, the negative of negative 6 is 6. And 6 minus 12 is negative 6. Oh, so this is the ordered pair, negative 6, negative 6. Again, get done with the test early. Plug negative 6 in for x and y into both of these equations and make sure it works. If it doesn't, you know you did something wrong and you still have time to fix it. All right, so we use substitution with that one. What's your thoughts on this one? 7x plus 5y equals 2, 8x minus 9y equals 17. What are you thinking? Good substitution problem? Probably not, right? Lots of different fractions in there. All right, so let's try and find something that's not too awful. 7 and 8, what's the smallest number we could get those two to match up with as opposites? Eesh, that's kind of big. Okay, how about 5 and 9? 45, but this one already has a negative as well. So that's probably the better way to go. So we'll multiply the top one by 9. And the bottom equation by 5. And let's see what we get. Remember, multiply everything. Both sides, all the terms. So far, so good? All right, let's see what we get. Oh, look at that. That's going to be nice. Lots of big numbers, but leads us to x equals 1. Not done, though. What do you think? First one or second one? First one, smaller numbers, no negatives. So 7 times our little 1 plus 5y equals 2. 7 plus 5y equals 2. Subtracting 7. Yay us. If we were going to put stuff with fractions on the test, they're going to be nice fractions. Things like 1/4, 1/2, 3/4. You know, they're not going to be weird fractions. So hopefully you'll get to this point and go, yes, well, at least I know I got nice integers, you know. But again, Double check. Now, before you flip the page, what would you write if when you got done, it said 0 equals 0? Infinitely many solutions. How about if you get something goofy like 7 equals 3? Then what do you write? No solutions, right. So sometimes it isn't that you're doing the math wrong, it's just that it doesn't have any solutions. So know that that could happen. I mean, we have 4 of them there. One of them might have something like that going on. All right. Still feeling good about substitution and elimination? Okay. So let's move on. The next section was about graphing the solutions to the systems. So take a look at number 6. We talking about lines, or is one a line and one a V? What do we got? Couple of lines. All right. So I'm going to color code the top one red like this. Remember, we pretend it says equals. Do we have a quick way to graph that one? That's slope-intercept, isn't it? So where would that line start? Up 5. How do I get another point? Okay, and slope is? Good, -1/1. Good. Always using that as a little fraction. So down 1 and right 1. I probably wouldn't even dash that up. Is that dashed or solid? Yeah, it does have an equals bar, so it's solid. What else do we have left to do before we can move to the other equation? Yeah, we got to test a point. So let's test 0, 0 and see if that's going to work. Come on, smartboard, wake up. There we go. 0 is greater than or equal to 0 plus 5. 0 is greater than or equal to 5. Is it? No, that's silly. So we can't shade towards 0, 0. Got to shade out that way. All right. And I'm going to color code the second one in green. Slope-intercept or thumb method? Thumb method's the faster one with this one because of the standard form. If x is 0, 3 times something is 15. What's the something? 5. If y is 0, this is gone, so we'd probably say, oh, let's divide by 2. It's 15 halves or 7.5, 7.5. I mean, we're graphing it, so we just have to know where to put our points. So there's that 0, 5 again. And then we have 7.5, 0. Is that one going to be dashed or solid? That one's solid. It has an equals bar. What's left for us to do? Are we done? What's left? Yeah, we haven't shaded yet. Better try 0, 0, right? 0 plus 0 is less than or equal to 15. Is it? Oh, so this time we shade this way. Now, how do we finish this up to show we know exactly what we're doing? Yeah, lots of shading with red and green for me. Overshade. We're saying, hey, we know that's where the double shading was taking place. Right there. Still doing okay? Yeah, because I'm looking out here when I'm asking questions. I see your heads are down and you're just going like crazy on these. Good, good, good. Alrighty, number 7. 2 lines again? A line and a, yeah, V. A line and a V. Now, that gets dangerous because, you know, the points come from knowing that that's a V. You might want to write that down right away when you see the absolute value. So you remember, that can't be a line. That's got to be a V. Let's graph that top one. Oh, you guys are going to say that's a piece of cake, right? What form is that in? Yeah, y equals mx plus b again. So where does that graph start? Down 5. Where do we go from there? I only have 1 point. Help me out because I know you're doing it. Where do you go? Down 1, right 1. And then I'll use slope backwards to get myself up here a ways. Dashed or solid? Solid. Has an equals bar. Let's test out 0, 0. 0 is greater than or equal to -5. Is that true? That is true. So we have to shade towards 0, 0. All right, I'll do my V in red. I went ahead and wrote our little generic equation up there, so hopefully we won't mess up. Y equals A, absolute value of x minus h plus k. So what important point should we start the graph of this one with? The vertex, yeah. I mean, that's the big deal. Vertex. Where is the vertex for this one? Good. Remember, opposites for this. -3, 1. All right. 1, 2, 3. There. It's right there. But that's not a V yet. How do I get the start of a V? Use A. What do I use A for? Slope of the right side. Slope of the right side is -3 over 1. So from my little red point I have up there, I have to go down 3 and right 1. But I remember, it was not a line. So I slow down for a second. How do I get the other half of this? Yeah, use opposites. Now, some of you like to put that axis of symmetry in here. You can do that. Some of you use opposite slope. I don't care how you do it, as long as we can get down 3 and left 1. I will be able to make out what it was you were doing when I look at that. Alrighty. Dashed or solid? This one's dashed, isn't it? Doesn't have an equals bar. So this has a lot more interesting stuff going on. And what's the last thing we don't want to forget? Yeah, shading. So this is less than. Again, they're usually y equals a x minus h in absolute value bars plus k. And less than means shade down. But you could test a point. So we could test 0, 0. 0 is less than -3 times the absolute value of 0 plus 3 plus 1. What's 0 plus 3? 3. What's the absolute value of 3? 3 times -3 is? -9. What's -9 plus 1? Is 0 less than -8? No. So we would have to shade inside, because with V's, you either shade inside or you shade outside, and we just said outside doesn't work because 0, 0 didn't work. Can you make out where you have your double shading? This little piece right here. A little itty bit of double shading. All right, is that coming back to you now? Excellent. Again, you were really good at graphing this stuff on the 2.6 to 2.8 test, so that is good. All right. Remember yesterday, I said we can't give you one problem about 3-4 because if you can't get the constraints and the objective functions down, well, then you can't do the rest of the problem. So we're going to give you pieces of that. So this already has the constraints for us, already has the objective function. Our job is to very carefully graph it, find the vertices, and then plug them in because they want, maximum and minimum. So we'll have to give them both. So graph each system of constraints, name all those vertices, find the values of x and y that maximize and minimize the objective function. Well, let's start at the beginning. I will color code this top one in red. That's a good one for thumb method, isn't it? Very nice and easy one for thumb method. Because if one of them's 0, what does the other one have to be? It has to be 5 because they have to add to 5. So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Dashed or solid. Yep. In fact, while we're looking at that, does everybody see all of these are solid? Usually with our real world problems, they're going to be solid. Okay, can you test 0, 0 in there for me, please? Did it work? So we're shading this direction back towards 0, 0. Done on that one, but a couple more. So let me go with green. For x plus 2y is less than or equal to 8. Slope-intercept form or standard form? And the green. Standard. Thumb method is the fastest way to go. No x's. What would y have to be? Has to be 4, because 2 times 4 is 8. Y is 0. This is gone. What does x have to be? 8, because 8 plus 0 would give you 8. Oh, those were both kind of nice and easy ones, right? 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Ooh, 8's right there on the line, right at the end. And like we talked about before, all of these were solid. So this next one's going to be the big deal. We got to test and see. Are we shading in towards 0, 0, or are we shading out? Which way is it? In towards 0, 0 or out? In. 0 is less than or equal to 8. Alrighty. What do these last two tell us? First quadrant. So let's just do this. Make our big 90-degree angle here. And then we won't have so much shading that we get lost. Because this way, in mine, it's red and green. I have to check where red and green are hitting each other. Quadrilateral, right? So how many vertices? 4. And this time we got lucky. 3 of them are nice. One of them we're going to have to hope we graphed perfect. Or we'll have to find it. Alrighty, so nice ones. 0, 0. The green one gave me 0, 4. Oh, come on, blue. Behave yourself. Just for 1 second. And it moved everything. You ornery thing. There we go. I gotta get somebody out to fix my blue. This bugger in the red was 5, 0. I would say 3, 2 on mine. What do you think? Is it looking like 3, 2 on yours? Well, I'm going to put a question mark by it. I think it's 3, 2. Do you remember how we can figure that out? Yeah, plug it in and make sure it works and it gets exactly 5 and 8. If it does, then you've got the right points. So is 3 plus 2 equal to 5? Oh, that's good news. How about 3 plus 2 times 2? Does that equal 8? Buggers. So that means we have to figure out where they're going to hit each other. So 1, 2, 3. It really looked like 3, 2 right there. So now, tomorrow you have a choice. Remember, you can get y equals alone on each one of these, and you can use your graphing calculator to find the intersections. Or you can do substitution or elimination with these. So we've got x plus y equals 5. Oh, I better keep these color-coded. And x plus 2y equals 8. So substitution would work really great with this one. We've got lots that we could do substitution for. So I'll subtract x from both sides and plop that in here for y. And let's figure out what the x is. So this will be x minus 2x plus 10 equals 8. X minus 2x is a negative 1x. And then we'd subtract 10 from both sides and divide by negative 1. Yeah, certainly on my graph it did not look like x was going to be 2. So if x plus y has to equal 5 and x is 2, what does y have to be? 3. So it was 2, 3. Did any of you have that look and you were straighter lines and it looked like you could do 2, 3? Okay, good. So you wouldn't have had to do this. My graph didn't line up with that. So now I'm going to write down my vertices and go through the step of finding the maximum and minimum. Oh, it only wants the minimum down here. So we'll just put the minimum down there. We'll get both, but I don't even remember what the objective function was. Better go look that up. P equals x plus 3y. All right, let's put a 2 and a 3 in here. So 2 plus 3 times 3. What's 3 times 3? 9 plus 2? 0 plus 3 times 0. Yeah, that might end up being our minimum, but let's keep going and look. So 0, 4 would give us 0 plus 3 times 4. What's that? 12. And 5 plus 3 times 0. What's that one? So if they only want the minimum, we're going to have to put a minimum of 0 at 0, 0. So minimum of 0 occurs at 0, 0. So you'll just have to read the problem and see. Does it say give the maximum? Does it see the... What if it said give the max, which it probably would anyway? Maximum of 12 occurs at 0, 4, right. So it's just which one's the smallest, which one's the biggest, and go from there. All right, let me check time here. Hopefully we've still got plenty of time left. Good. So this is the one that the other day I did a review with you in class 4. We got money. $5.55 worth of change in your pocket. You realize that you only have dimes and quarters. You count out 33 coins. How many dimes and quarters do you have? So somebody please write down one equation and then tell me what you wrote. Excellent. There we go. Good substitution problem, right? So let's subtract x from both sides and do some substituting. And yeah, I've got the calculator up here so I can punch some of this in for you if you don't have one with you today. All right, so we will have 0.10x minus 0.25x, and then we need 33 quarters. $8.25. Well, a dime x minus a quarter x is going to be a negative 15 cents x. Whoops, I don't want to do 2 steps at once here. I don't want to lose anybody. Subtract 8.25 from both sides. So 5.55 minus 8.25. Negative $2.70. And what's my last step so I can figure out what x is? Last step so I can get x. I don't have any room. I'll put it over here. So I've got my negative 270. Got to divide that by a negative 15 cents. Woohoo! 18 what? Together we had 33, right? 33 minus 18 is 15. And there it is. So that's probably the 5th one of those that we've done. You know, we're definitely going to have something like that on the test. Might not be dimes and quarters, might be nickels and dimes, you never know, but one like that. And then we had problems like this. You're selling tickets for a high school concert. Student tickets cost $8. General admission tickets cost $15. You sell 575 tickets and collect, $6,840. How many of each type of ticket did you sell? Set them up. Somebody have one they can share? Beautiful. What's the other one? There it is. So again, really good substitution problem by just subtracting x from both sides. So 8x plus 15 times negative x plus 575 equals 6,840. So big numbers, but we can use a calculator. 8x minus 15x plus 575 times 15. 8,625. 8 minus 15, negative 7x. Subtract 8625 from both sides. And divide by negative 7. $255 somethings. So which one did we use for X? Did we use student tickets for X or general admission for X? Student tickets. So 255 student tickets. Well, together there were 575 tickets. So if we just take 575 minus our 255, there it is, 320, general admission. So once you get it set up, like you were talking about with the other substitution and elimination problems, it's pretty basic algebra. I mean, the numbers aren't real nice with word problems, but you just have to be careful. All right, everybody have what they need off of that one. I realize we're going a little faster here because we're going to run out of time. List all the points that are solutions. Oh, well, here's the double shaded part. So what absolutely is a solution in this thing? C. But there's another one. Do you see it? Yeah, D. Because this is a solid line. Remember, the solid lines, they're solutions. Does B count? No, that's dashed. Dashed lines are just boundary lines. They're not solutions. So both C and D. One more to go. We can do it. You ready? All we have to do is set this one up. That's it. We don't have to find the answers or anything like that. A city wants to plant maple and spruce trees to absorb carbon dioxide. If it has $3,600 to spend on planting spruce and maple trees, and they have 86,000 square feet available for planting, use the information in the chart. How many types of each tree should the city plant to maximize carbon dioxide absorption? So what we're going to do is we're going to write the constraints, and we're going to write the objective function, and that's going to be it. And actually, it's in the reverse order. So they wanted to maximize carbon dioxide absorption. So I'm going to call that C. What do we know about the carbon dioxide absorption? Well, just what they tell us in the table. 750x plus 600y. That's the objective function. So we're not going to use that again. And I go back in the reading and I see one of the totals they had was $3,600 was how much they're going to spend. So do they want to spend more than that? No. Less than or equal to. Go to the table. Do we know anything about the cost? Of course we do. 70x plus 80y. Their other total up there was 86,000 square feet for planting. So do you suppose that means they have unlimited space for planting? Well, then we can't put greater than. It has to be less than or equal to again. Does the table tell us stuff about how much space you need for these trees? Yeah, there's the area. And is this a word problem? So what two constraints are we supposed to know have to go up there? And we don't have to find them. This one is just set it up. Jack.
I have a question about the logistics of this. So, the spruce is cheaper, requires less space, and has higher absorption.
So that's the reason we're just having you set this one up and not actually
The
find
answer
it.
would just be 630 divided by 70. That would just be the answer.
Exactly. So just setting it up is all we're going to ask you to do on this one. And then this is the same assignment you have on that little slip. Now, it was already really, really shortened. I went through again last week, and I made it so this is almost exactly the same type of problems you're going to see on the test with no spares. So if you do this and you study your practice test, this should be a fabulous test for everybody.